So study guide will be in the Schoology. There'll be a special folder. I believe I called it test review or something like that. That you can look at, and you can use that along with your notes on the test. And then, like I said, Thursday will be, or Friday for this group, Friday will be the test. I'll have it open all day. So you can find a time to take care of that. Any questions? Again, feel free. You can always choose to send a private chat message, which some people have found to be really helpful. If you don't want to unmute and talk to me that way. All right, so sharing my screen. So 11.5 is called margin of error, and it is used often when survey results are given. A lot of times you'll see, especially during elections, that 62% of people prefer candidate A, and then in the bottom corner, usually it'll say plus or minus a certain percent, and that's margin of error. And we'll talk about how that is calculated in about 10 minutes. All right, so Seth selects a random sample of students from a local college. He asks students their year in college and how far the college is from their home in miles. How can Seth's sample estimate the proportion of freshmen in the population? And how accurate is the estimate likely to be? So if we look at Seth's data, and we want to know the number of freshmen. So I'm just going to highlight if someone is a freshman or not. So how can Seth's sample estimate the proportion of freshmen? Well, we're going to take the number of freshmen and divide by the total sample size. Four, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 20 people in his sample. So you could write this as a fraction. You could also write it as a percentage. You could also write it as a decimal. Any of those three would be the proportion, your sample proportion. And how accurate is this estimate likely to be? So think about a college and how many students um, go to any particular college. For instance, um, there are, I would say, hundreds of students that attend Inver Hills. There are thousands of students that attend um, the University of Minnesota, um, and many other colleges. So, do you think, and you can certainly message or unmute and give me an answer. I'm going to bring back the video panel. There we go. Do you think choosing 20 people is an accurate representation of hundreds to maybe thousands of people? Okay. So I've already got one no. So how accurate is the estimate? Probably not very accurate. And it's not very accurate because of the small sample. So that's Seth's data and number of freshmen. Now we're going to move on to Tia. And Tia is contributing to the same project as Seth and has sampled a different group of students. The proportion of freshmen in her sample is 40% or 0.40. How can Seth and Tia determine whose result is a better representation of the population? All right. So again, first thing I would maybe do is double check my data. 1, 2, 3, 4, 5, 6, 7, 8 out of 20. That's 40%. Got that. So we want to know, how can we determine which is a better estimate for the number of freshmen at this college? Is it 20% or is it 40%? All right, you can't see the screen. Let me see if I can get that fixed. I'm gonna pause. All right, so how could we determine whose result is a better representation? A couple of things. No, I can't remember our other Seth. All right. So Seth and Tia could take a larger sample and see what percent they could calculate the proportion of freshmen in that sample. That's one way. Another possibility would be that Seth and Tia could actually ask the college for that data. Most colleges can tell you how many freshmen, sophomore, juniors, and seniors there are attending that school. So there would be a way to get that exact proportion. All right, moving on. Each classmate calculates the mean or the average distance from home in miles reported by participants in their survey. Seth and Tia create this histogram to investigate the sample statistics. How many samples reported an average distance from home between 101 and 125 miles? Use the histogram to suggest a reasonable interval or range to estimate the population parameter, which is average distance students travel from home. So we're going to do a little poll, and I am going to set that up. It just takes a minute. All right, now you should be able to go to go to the bottom of your screen and click on poll and make a guess. And I'm pretty sure there's more than one of you out there. All right, 5 more left to vote. So I will give you 15 seconds. And 5, 4, 3, 2, 1, ending the poll. And by a landslide, 6 is the answer that came up the most often. So if we look, what the question is asking really is how many samples are in that 101 to 125, and I agree, 6 looks good. So there are about 6 samples. That reported an average distance between 101 and 125 miles. All right. The next question is one that I think students struggle with because they want to be really precise and really particular. It says, use the histogram to suggest a reasonable interval or range to estimate the population parameter. So if we surveyed every student in that college and calculated the average distance they are from home, where would that be? And, you know, I think a lot of times we look at that and we want to say, oh, I think it'd be between 76 and 100. But that might not be a big enough range to include the actual average. So what we want to do is pick a range that includes almost all of the data. So I would maybe go from 26 to 125. And we should have most of our data then, or we should be pretty comfortable that the actual mean would fall in between those. And that's a hard one to say, well, it's got to be this or it's got to be that. Um, just know we want to pick, in this case, a range that includes most of the data. All right, moving on. So the sampling distribution of means and proportions tend to be normal. The mean of such a sampling distribution is called the population parameter, and the standard deviation decreases as the sample size increases. And we kind of talked about that a little bit when we said that the sample size needed to be larger for Seth and Tia in order to better approximate the percentage of freshmen at the college. And so here we're actually saying, this is what happens. Our standard deviation, the amount that we vary from the mean, gets smaller as the number of people that we survey, or the bigger our sample size gets. As that gets larger, the variation gets smaller. All right, moving on. So the big part of today is something called margin of error, and that is the maximum expected difference between the sample result and the population parameter. So in this picture, the estimate, this would be our sample result. And our margin of error, this is the range that we expect the actual population parameter to fall in. And we'll actually be able to say we can be certain to a specific percent of time where that is true based on our margin of error formula. All right, so if we have quantitative data, this would be like the number of miles from home, the number of pets in a given group of people, shoe size, things like that, things that are measured and have a numeric value associated with them. Our formula for the margin of error, so MOE, margin of error, is 2 times the standard deviation divided by the square root of n. So just a few notes. That's the standard deviation. And n is our sample size. Right? So in order to use this formula, our data has to be quantitative, it has to be numeric. And one thing I should include, we always talk about this being plus or minus. So this will give us a range that we think the average or the number or whatever falls in. For categorical data, this would be the number of people that prefer a certain candidate, the number of people that have a favorite color that's puce, things that aren't numeric. That is just 1 over the square root of n. And again, it's plus or minus. This is the sample size, n. And the formula for categorical data is usually a percent. And this one is usually, bad U, there we go. Usually a number. And you'll see as we get into a couple of examples. All right. All right, so here's an example. The College Board recently reported that the mean score on the SAT mathematics exam is 508 with a standard deviation of 121. Washington High believes that their seniors score considerably higher than the national average. So the school randomly sampled scores from 200 seniors, finding a mean score of 550. Is Washington High correct in its belief? So here we're going to do a quick poll again. Maybe. All right, so again, if you go to your bottom of your screen where there's, oh, you know what? I bet, did I launch the poll? No, I did not. Wish I could get these pre-typed and then it wouldn't take me so long to. All right, I'm not. All right, that's not working. How about going to chat? Go ahead and chat if you think it's quantitative or categorical. And just type that in. I'll even make it easy. Use Q for quantitative and C for categorical. All right, a couple of different thoughts here. Coming up with, it looks like, a majority. So, I think I just saw a couple more come up when okay. So one way that you can think about this, I'm going to move that. I like to circle all of my values when I have a word problem. I like to circle my numbers. That was a bad circle. And then kind of highlight some of the important pieces. Mean score, standard deviation, sampled seniors, and mean score. So if this is quantitative, I should know or be able to find the standard deviation. And we're given the standard deviation here of 121. So I agree that this is quantitative. Because it's quantitative, our margin of error is going to be plus or minus 2 times the standard deviation divided by the number of students in our sample, in this case 200. And I'm going to estimate to the nearest point, the nearest whole point, because that will be kind of easier to compare values with. So I'm going to do a new share. And on my calculator, I am going to calculate the margin of error. 2 times 121 divided by the square root of 200. 200. There we go. And that gives me about a 17 if I round to the nearest whole number. So that would mean plus or minus 17. Now, here's the big part, the evaluate. So what does that tell us about the data? So that means about 95%. And the reason we can say 95% is because we said that the means are approximately normal. So we've got that normal distribution, and we went 2 times the standard deviation. Remember, 95% of our data from the empirical rule would be within 2 standard deviations. So about 95% of random samples with 200 participants will have mean values within 17 points of the population parameter. And so the population parameter is the average SAT mathematics score of 508. So that's just using the information given using our margin of error calculation. To find the range of reasonable means, we're going to take the population parameter and add and subtract the margin of error. So in this case, we would take 508 minus 17 and 508 plus 17. All right, so Washington High's sample mean score of 550. How does that compare to our range of values? So it looks like, yeah, is greater or above the range of reasonable means. So they can conclude that their seniors perform better. Than the national average. So if it would have been between 491 and 525, we couldn't say that they were better for sure. They still might have, but the data doesn't support that. So we just want to be careful with how we state that. All right, one more example. A random sample of, and this is missing a value. So I'm going to put that in. This should say a random sample of 90 Simile seniors reveal that 20% plan to take the SAT this year. Using the margin of error to predict, use the margin of error to predict the actual proportion of seniors planning to take the SAT. So again, is this quantitative or categorical? Go ahead and chat either Q or C. Looking good. I'm liking it. think we have a unanimous decision on the type of data, and it is categorical. Basically, in our survey, we're saying, are you taking the SAT? They're answering yes or no. That's not a quantity, that's not a value. It's just a yes or a no. So for our margin of error, we're going to take 1 over the square root of the number of people in the sample, in this case 90. So you can see where leaving that value out made it, would have made it impossible to calculate the margin of error. And again, I'm going to round this to the nearest whole percent. So I'm going to do a new share. Um, 1 divided by the square root of 90. And so as a percent, that would be 10.54%. Remember, taking that division and multiplying by 100 gives us a percentage. So if I round to the nearest whole percent, I'm going to call that 11%. So in this case, in about 95% of random samples with 90 participants, the sample proportion is between, so we have to calculate that again. So we're going to take our sample proportion plus or minus our margin of error. So 20 minus 11 and 20 plus 11 would be between 9% and 31%. Right, questions? So what I'm going to do is finish attendance, and then I will go and put the assignment and the note check and the review information out on Schoology. So it'll take just a minute or two after attendance is done. So don't go right out there right now and say, Mr. Gingrich, I don't see it. You're right, you don't. It's not there yet, but it will be shortly. So again, when I call your name, give me a thumbs up reaction or unmute and wish me a good day or something. Or if you need to talk about something, you could unmute and just say, hey, can we meet? And then once everyone is done, we can have a little meeting about whatever you need. And before I do that, I'm going to stop recording.